Okay. Okay. So thank you. Okay. Thank you, Kyle. Okay. So welcome to our animation workshop. We're going to review what animation is and how it works in video games. We hope you like the outcome so far. So please enjoy. And let's begin then. Now, let's see a quick overview of the content we are going to cover today. It will be 4 sections, so please make yourself comfortable and be ready to take some notes, just as the same rules applies of the last workshop. So let's go then. Now, let's begin with our first part and let's answer this essential question. What is animation? We can say there are two ways to produce it. The first one is traditional animation, in which images are drawn or painted by hand, and the other one is digital animation, in which, as the name suggests, is using a computer to produce these kinds of images and movement. For video games, you can use mostly digital animation. But now, but now with the release of Cuphead, now we can see that there are ways to combine them. Let's remember that animation is always evolving. As you can see right here in this GIF, uh, sponsored by Disney. Now, how animation works in video games. We call it interactive animation. Why? Because games are meant to be interactive. Since you have almost complete control of the character, you're the one driving the story forward and making a character move. Not only the animation needs to look good, but it also needs to express what the player needs to understand about the world he's immersed in. Now, remember that animation always evolves? Well, let's take a look at how animations have been depicted in video games over the years. But before, let's take a look at this quick glimpse. This is the game Super Mario Odyssey. Why do we call it an interactive animation? As you can see here, in this case, what are the things that are animated? First is Mario. Mario is running. He's running in the direction we are pointing in the using the controller, and you can see two enemies. Well, I think three in this case. The enemies can attack you, or they can just like walk around. Those are two kinds of different animation, of course, but they are interactive since the player is the one that triggers it. So very important definition. Now let's continue then. Now let's see how animation has been evolving over the years in video games. First, we have the pixels era, which is a very early stage of how animation was in video games at that moment. We can see that while we can recognize the character and various elements of the environment, we can understand, for example, how the character behaves, if he's happy, if there's any kind of movement on the back elements. Everything seems so stiff, yet amazing for those years. The main point of this stage was to just tell a story with visuals, but with no understanding about what is going on. As you can see in this little GIF, okay, we are using Super Mario Bros. Examples. They are just like okay, walking and running, but we can really see what is really happening. We can just see everything like so stiff, as I said, and so on. Now, second, we have the 2D and 3D animation era, which is the concept stage. Now we can see more feedback of the character and the elements surrounding them. We can see more clear expressions, more ways to understand if we are doing things right, and even understand what's better what is happening. The goal of this stage was to experiment with more ways of doing animation. Since for these years the animation movies market was getting stronger, the video games needed to evolve the same way. So now, onto the next stage, the last stage. We're now with a full understanding of how animation can be better, as you can see in this GIF. Again, Super Mario Odyssey. It is an enhanced version of the previous one. We are at the innovation era, also known as the combination era, which is our current stage, where now that everyone can choose which style of animation fits better for their game, they can even manage to create combination. As you can see here, for example, is in this game called Paper Mario, where they combine 2D with 3D. And other examples include pixels with 3D, as you can see here, in this game called Octopath Traveler. Great. Now that you know how animation has been evolving in the video game industry, we need to cover the techniques and standards used to accomplish it. The animation principles, which are the steps to make your animation come to life. Now, back when video games were still in the pixel era, Disney animators introduced what is now widely held to be the core tenets of all animation, the 12 basic principles. They can be interpreted in many ways depending on the area you come from. In this case, we are going to cover each one of them through the lens of video game animation. So, let's begin then. Squash and stretch, the very first one. It is a technique of squashing or stretching elements of a character or object. They can be used to emphasize many aspects, such as elasticity or a cartoony style, in this case. One of the games that clearly had this principle as one of its main features in the animation style is Yoshi's Story for the Nintendo 64. You can see how when Yoshi moves, it, or even lands, it literally deforms in order to accomplish a cute and very cartoony style of animation. Even the enemies in the game have this same trait. So, as you can see in this quick example, this is a very old game, yes, but I believe its animation style is heavily inspired by the squash and stretch principle. So this is just an example of how it works. Now, on to the next one. The second one, staging. This is one of my favorites. Is staging. So, which can be translated in game as the principle of any idea that is completely and unmistakably clear. This is completely true for games like The Legend of Zelda, in which using the camera, as you can see in this example, lighting, or even character composition, well, they can lead the player to focus its attention on what is relevant to that scene while you avoiding unnecessary detail and confusion. So, for example, right here, this game is Breath of the Wild. We can see Link, okay, like just standing there, and we can see a lot of fishes and this chest in the middle of the scenario. So what the camera is doing right now is using this principle to show the player where is like the prize. In this case, the chest. Another example in the same games are, for example, in any boss fight when you finish the battle, a hair container appears and its staging gives you the feeling of accomplishment and that you can grab your reward. This is more like a cutscene, but in any case, they are using this principle heavily. So, on to the next one. Anticipation. Anticipation is used to prepare the player for an action, such as crouch before a jump or an arm pulling back for a punch. One very clear example is in, again, the Lane of Zelda, in this case, Wind Waker. Whenever you are close to an enemy, Link starts to change its expression and body language because he's feeling something bad is approaching, as you can see here. Like he's like, okay, something is not right here. It's not right, so they need to be prepared. And also, in any game where you use a sword, the character will usually build up energy in order to use up the weapon. This is more clear when the player is carrying a heavy weapon. Again, using the same game, we can see the example right here where Link used first the sword, the Master Sword in this case. So we can see here they are applying the anticipation principle here, but they are also applying another principle that is called timing. However, we are not going to cover that right now, so let's just wait. Now, on to the next one. Pose to pose. It refers purely to the process of animation creation. This is also called blocking, wherein the animation you only use the key poses to allow the animator to blend each pose into one single move in order to quickly create how you want your character to move like. In this case, I'm using this example. It's Link from the Super Smash Bros. For Wii U. If you separate the animation by frames, we can see that this whole animation sequence has 15 frames. So the animators, when they were animating, in this case this character, they use 15 animation, as you can see here. The blocking literally is just posing the player, posing the character you are animating in the key pose for each frame. Now, for video games, blocking can be used not only in the process but in the final animation too. Now, a great example is Pokemon Mystery Dungeon, where we can see the characters just moving in three different key poses. They do not need no they don't need more poses since it is used only to show how the characters are behaving. In this case, it is kind of funny in my perspective, but you can see here, like, okay, in this game, as you can see, they use sprites or pixels. We can see that, okay, each Pokemon has like three key poses, but we can clearly notice how they are behaving. If they are like maybe happy or just talking or just like be there, standing there. Now, on to the next one, follow through. The next one, which can be also known as the overlapping action, which describes what takes place after an action, it is basically the inverse of anticipation. How? Well, discovers the notion that different parts of a character body will move at different rates. In this example, as you can see right here, from taking from the video game Luigi's Mansion 3, Luigi is grabbing something. The action that takes place after is its expression and his head moves. We can see how the nose, the mouth, and even the mustache moves at different rates, giving us a sense of natural animation. Now, on to the next one. Slow in and slow out. It describes the visual result of acceleration and deceleration on moving elements. This principle is the main kind of animation we see on video games that use weapons. In this case, shooter genre. One perfect example is Halo. Depending on the weapons you're carrying, we can see how the weapon builds up energy to shoot in very high speed the bullet. The heavier the weapon, the clearer we can see this principle in action. On to the next one, the arcs. The arcs is related to the natural action we make that are followed by an arc, literally, such as arms and legs swinging while walking, for example. The arcs help the character movement to feel more natural. We can see it when a swordsman uses its sword, for example, right here. Now, a game that uses this principle as its main feature is called Mario Golf, where the character always needs to swing. We can clearly see the arcs in the arms, in the knees, and even in the faces when they look at the ball. Woo. Now, onto the next one, the that is called the secondary action. The secondary action is used to emphasize the primary action a character does, adding extra detail and visual appeal to the base action. In this example, taking a game for the game Super Mario Odyssey, since Mario is possessing a frog using his hat, the secondary action is the hat movement when Mario realizes he's the frog. Right now, let's see it again. And we can see right now. Yes. Now, on to the next one. The next one, and also one of my favorites, is the appeal. This should be the goal of every animator when bringing a character to life. Why? Because we can say that this principle is the magic element that causes players to believe in the character they are interacting with. This is especially true for games such as Super Smash Bros., where, regardless of the character you are using, by pressing a certain button, you can make a single animation that emphasizes the feeling of the character. In this case, I am using Mewtwo and Princess Zelda from Pokemon and the Legend of Zelda games. Mewtwo, for example, what is its main appeal, or what we can say it's the main appeal? Well, basically that he's some like evil mindness or something like that, and that we can also perceive that he's like strong enough and he can float. Now, for Princess Zelda, we can see like, that she tends to use magic, and of course, he uses mostly like move or she moves like well, how to say this more gracefully and like delicate to say something. So as I explained here, we can see how appeal brings literally the character uh, to a mm, to another well level of characterization. Yes, that's the word. Now let's go to the next one. Timing. Remember when I showed you the GIF where Link uses the Master's Sword? Well, timing is also there. Now, where is timing? Timing is generally invoked to convey the weight of the character or object. We can say that it is linked to speed since it's the time it takes for an object to move or rotate. Mostly, if you play any Super Smash Bros. Game, you can see how whenever you throw a punch or do any like move with any character, you can see whenever the character hits something, it's going to freeze for a couple of seconds. That is actually uh, another technical term that I forgot right now, but I believe it's called hit stop, or maybe yeah, I believe it's hit stop. So whenever you have time, search for it. Now let's go to the next one. Exaggeration. Real life never looks real enough. And with this, the next one, as I say, is called exaggeration. In animation, usually we want to emphasize the world we are creating through the game. This principle is an advanced version of squash and stretch. This principle is the main feature for games like, as I mentioned earlier, Luigi's Mansion, where whenever a ghost appears, it has its own exaggeration animation. In this case, we can see how the this ghost mouth increases or literally it it gets big whenever he's like crying. In this case, even when Luigi is scared, he has its own exaggeration animation, and this carries over for the next titles in the franchise. Hmm. Now, and lastly but not least, solid drawing. This principle is used to understand the body mechanics of a character, the volume of an object, or the size of an environment. As the name suggests, it's basically the draw of everything and how it transfers to the animation you want to create. Um, in this example, well, it is not quite an example because solid drawing is basically your sketch. When you want to when you are before you start creating the animation in the software, you need to have or a sketch or maybe a plan. Let's just say in a way, you need to have a plan in order to know where how many frames you are going to use, what the character will do in each of those frames, and of course, if it's going to transition into another animation and so on. Now that we know the principles, in this case the theory, let's practice a bit using the animator tool of Unity. Now, before we start, something that I must say is that Unity is not really a tool for complex animations. You should use it only if you want to create basic and quick animation for your video game without using third-party software. Now, I'm going to open my Unity. Uh, Kyle, you can see the screen? I believe so.
We can see the screen.
Thank you. Okay, so what we have here, I opened this quick project. So let's do like a quick review of what Unity is or does. So what I did here, if you when you open Unity, you will have your these five windows. Well, I organize them like this, but normally you will only have like one big screen, and below that is your like project window. But I recommend you this way of organize your views, since it's the easiest way when you are programming a video game. So why? Because here you can see the scene window. Below that you can see the game window. That is basically how it will look in the game in game. And then the next one, on the side of the scene window, is the hierarchy, where you can see all of your objects. In this case, I use 3D objects. You will always have your main camera and your directional light. You can always personalize them, but it's like the default, what you can see in the default project, that if you want to create one. Now, below that is the project window. Here we can see all of our assets and and whatever our project has. As you can see right here, I only have like two main folders, that is assets and package. I want you to focus only on the assets folder. Here we have two more folders. One is character, the other one scenes. And okay, this blue stuff thing is just a material I created for you to see more clearly the ball. Okay, and lastly but not least is the inspector animate window, where if you click, let's just say I'm going to click on my main camera. We can see all of the properties this project has. Sorry, this object has, and all objects will have a transform. What is a transform? Is basically where it is located. It has the position of the object, the rotation of the object, and the scale. For 2D objects or sprites in this case, they have something that is very similar to transform, but it's called rectangle in this case. That is a way to, okay, if you when you are programming a 2D game, normally you are going to use like this plane with only x and y axis. So that's why instead of using a transform, the 2D objects uses only like a rectangle to to show you where it is located. So now, going back to animation, I just put this like plane right here, and this quick sphere. I created this blue material, to put on my sphere, so you can see clearly, like, woo. Now that my sphere is blue. You will have more insights on how to use Unity when you if you go to the coding workshop. So woo. So how we can create an animation. So in the window project right here we have another thing called console. That is it is basically, if when you are playing your game, this will show if you have any errors or any warnings. Warnings are not exactly errors, but are a way to it's a way for Unity to tell you that, okay, something may be well, wrong in your coding, but it's okay. And the next one is animation. Something that I need to say is the animation tab normally doesn't appear. So if you want it to appear, you need to go to Window, Animation, and activate it. Or as you can see here, use Control plus 6. Woo. Now, how can I create a quick animation? So when you have your animation window right here, you just need to click on the object you want to create an animation of. In this case, I'm going to use my sphere over here. Yes. So I click on my sphere, and then I go to the create button that is on the animation window. Create. Then another window is going to open inside your project, and you need to call it, let's call it awesome sphere. Excellent. Now, when you create your animation, in this case of this object, a timeline is going to appear. Also, when you create your very first animation in an object, another thing called uh, animation controller is going to appear. The animation controller is basically what Unity has in order to control and manage all of your clips. What are those clips? Each clip is a different animation. Okay, so in this case, for this sphere, uh, you can see right here the animation controller, and also this is a clip. As you can see right here, our very first clip, we call it Awesome Sphere. Great. Now, this clip contains nothing right now because we haven't done anything. So let's create something real quickly. Let's go and click again in the sphere. So first, if you want to start recording, well, recording in this case, your animation, just click on this red sphere. As you can see right here, it says enable/disable keyframe recording mode. So let's click on it. Yes. Now, everything, this timeline is going to turn red. It means that we are starting recording this animation. At first, we're not going to see like any keyframes or anything. So in order to just start, let's just move it a little bit. Then we can see that okay, two keyframes appeared. The keyframe that is on the highest part of the window is like the master keyframe, and then the one that is below is the position keyframe. Okay, it means that since I just move my sphere, this is why it it appeared here as a position keyframe. So what I'm going to do right now is if I believe you can see this white line here. Well, we can move it. I just need to click on it and just move it. So let's go to the second number 30. Now let's move my sphere right here. The same thing happened. Another keyframe appeared. So let's go and play it. Great. We managed to do a quick animation. Now we can see right here that what are these numbers? Basically, those numbers are the amount of keyframes we're using. So in this case, I am using 30 keyframes. Great. To move around. Now, what I did here is I I animate the position. Now, what happened if I want to animate my scale? Another thing that I can do is of the shortcuts. In this case, if you click on an object and use W, then it's going to move. If you click on in the E, then it's going to rotate. We can see it clearly since it's a ball, but at least in the scene window, we can see how it rotates or tries to rotate. And then if you press R, you can scale it. Oh. Now, did you notice that when I showed you how to scale and how to rotate, another keyframe appeared? Well, because they are different types of keyframes. In this case, right now I scaled it. So a scale keyframe appeared right here. Woo! So Control C, and let's do some squash and stretch. So I'm going to move these keyframes to the final part so we can have uh, more space to move it. Yes, sorry. Now let's animate the scale then. First, we need to put a single scale keyframe. So okay, we already did. Now let's go to the final part And let's try to do our squash and stretch principle. Okay, let's play it and see how it goes. Okay, what is wrong here? Basically, okay, we are using the squash and stretch principle, but the main error here is that we need timing. We need to declare in which frame it's going to start like squashing. In this case, in this animation, we can see that okay, it starts to to compress itself uh, as it is moving. So let's try and do this, but in a different frame to see how it goes. So what I'm going to do is I'm going to copy the scale keyframe, my very first scale keyframe. So I just need to click on it, Control C, and then right here, Control V. Great. As you can see right here, it is moving, but it retains the same scale. So let's play it and see what happens. Okay, only only let's say at the very last 5 frames, it starts to stretch, to squash and stretch. So we try to add some timing, and it is working, but it needs a little bit more of work. Let's try again. Great. Now let's try and animate some rotation, okay? But in this case, I am not going to use a sphere. I want to use a cube, so it is easier to see how it rotates. So to add a cube here, I just need to go right click here, 3D object, cube. Great, now we have a cube. The problem here is that since it's white, I need to put in another color so you can see it. So let's drag this material. Now, excellent. When you can repeat materials, so it's okay. And how you create materials? Well, here in the project window, right click, create material. Click on it. Oh, and then new material appears. So let's call this green stuff. Great. Now, now if you click on the material you just created and go to here on the main maps, albedo, you can then change the color. So let's just put it green. Now let's drag this and put it on our cube. Yes, now our cube is green. Now let's animate the rotation. So remember how to create an animation? Just go to the animation tab, click on the object you want to animate. Oh, sorry, in this case, the cube. Click on the create button. This new window is going to open, and let's call it Awesome Cube. Awesome Cube, enter to save, or just click on the save button. Woo. Now let's click on the red dot so we can start recording it, and let's start by rotating it a little bit. Great. Now we see that a rotation keyframe appeared. Now let's go to the frame number 20 and let's put it like this. There you are. Now let's see what happens. Let's play it. Woo. Now we can see the rotation. Now let's move it while it is rotating. Now, okay, we create a keyframe type position. Then again, let's play it. It kind of goes really quickly, but you get the point. Now, okay, what we learned so far. We know how to create basic animations with basic models. In this case, I use a sphere and I use a cube. Okay, but let's just say that I created a 3D character. If I put my 3D character in this project, what is going to happen? So I just have the right example to do this. So I imported this character that I created from a past video game that I developed. So basically, what I can do here is I need first I need to import the character. How do I do that? Just right click here, import new asset. When you click on it, you can import stuff here. So I imported this character. Now, when you import it, it's going to appear right here as an item. So you just need to drag it to the scene and we can see it. Okay, it is a pretty it's big. So let's modify its scale so we can see it. We can see the character better. And right here. Great. Oh, excellent. Now, okay. So for all the 3D animators out there, when when you animate your character in whichever software you are using, let's just say that when you export your character from those softwares, they are going to export it with their animations. So in this case, this character has a single clip. You can open it when you import your character here. If you click on this little triangle icon here, more things is going to appear that they are mostly part of the model and also materials of this character specifically. And then a clip, as you can see right here, appear. This clip contains basically all of the animation you did for this character in your 3D software. So if you click on this clip of this specific character and you press play, okay, you can see here how the character is moving, how it behaves, whatever the style you are giving to it, and we can see how many frames the animator used to create each animation of this character. In this case, we use almost maybe 400. Yeah, mostly. Now, what we already know. We know that when you create animation for an object, a clip is going to appear. Okay, so in this case, this is one clip with lots of animation. So what we need to do here is to cut each animation into separate clips. Okay, so to do this, you need to click on your 3D model right here that has animations. Oh, oh yes, right. On the 3D model right here, go to the animation tab, and right below it, you can see something here that it says clips, and it says take 001. So let's just say that this character has, if I'm not wrong, 5 different animations. Okay, so what I need to do is to enter whenever the animation starts and whenever the animation stops. So in this case, let's just play it and see. Let's cut the very first animation. In this case, the very first animation is called the idle animation. Why idle? Because it literally just stands there and move his little arms. And if we try to notice here, maybe at some point at the frame number 59, it ends. So in this case, the start of this animation is 0 and the end of this animation is a 59. We can see how our timeline shrinks. And let's call this the idle animation. Now, to add more clips right here, you need to press the plus button, and you can see right here that okay, it like duplicates itself, but we have our idle animation right here, and we can see where it starts and where it ends. Let's just play it. We literally just could cut the very first animation of this character. Yes, and we got the clips. Now, and you need to do this for the rest of the clips, or for the rest of each animation this character, at least in this case, this character has. Excellent. Now that I explained to you how the basic information of how animation works in Unity, let's go back to the presentation to conclude. Please, going to share my screen again. Okay. Okay. Now, back to our presentation. I believe everyone is looking at the presentation, I hope. So now let's conclude this presentation by giving you a few tips on animator stuff. So as we saw earlier in the presentation, depending on the type of animation you want to create, there are specific tools for each type. Here we put some recommendation we want to give it to you. For pixel animation, you can use Asset Sprite, a paid software with a lot of features, or Piskel, which is a free software that can help you when you start in this type of animation. Now, for 2D animations, Toon Boom is an industry standard uh, paid software. However, you can also use OpenToonz, which is also considered an industry standard, but it's free, so great. Obviously, each one has its own features, but I strongly recommend OpenToonz in my case. Now, for 3D animators, you can use Maya. Needless to say that plenty of movies have been animated here. However, it is a paid software. Or you can use Blender, an open source free software, and of course an indie standard. Uh, the ones that I use is 3D Max, Max, Maya, and OpenToonz. I'm not, but if you want, if you have more question on how it works, you can always ask me. Now, we at UBC Game Dev hope you like this workshop with the love just for you, and I really hope you like the the path of becoming a great animator. So, as we say here, always keep gaming, and I believe that's it for this workshop. Thank you.